Erik Darling here with Darling Data, and I'm taking a little break from my recording about various community tools and my little bit about series, which I don't know. I was going to call that Tip Jar Sequel because it's sort of like small little tidbits about things, but got lazy. Sort of forgot to go down that path. Anyway, I'm here to talk a little bit about I think a really disappointing feature in SQL Server 2022, and that is the degree of parallelism feedback. Talk about the four reasons why I find it personally disappointing, and then I'm going to talk about some things that I think would make better additions to the intelligent query. Well, probably one thing that would make a better addition to the intelligent query processing set of features that have permeated SQL Server since 2016 or so. Maybe 2017, who knows? One of those years. Sometimes it's hard to tell the difference between 2016 and 2017 in retrospect. So the first of the things that I dislike about the feature is that it only tests DOP downgrades. It'll only look at a query currently going parallel, let's say max DOP 16, and then look at the weights and the time for it, and then see if downgrading it to a lower DOP doesn't detract from any query efficiency. And then if that is successful, then it will be persisted in query store enable. There'll be one of the query feedback items in there. So that's that's useless at best for most people. Most people have DOP moderately correctly configured on their server, and testing minor downgrades to that is quite a waste of SQL Server's time and of your money. You're paying $7,000 a core for SQL Server to figure out if a query can run at the same speed at a lower DOP by like 2 or 4 or something. It only tests downgrades to DOP 2, which means that you will have at best a minorly parallel plan. SQL Server will not test if going down to a single-threaded plan would not detract from query performance at all. So that's kind of silly, and I've been given, I think, some reasoning on that, and that it would require a recompile, which is just nonsense, because when SQL Server comes under sufficient CPU pressure, you will see a parallel plan, but the query itself will only be running at DOP 1. I have plenty of demos that show that, and they do not require a recompile. You still see a parallel plan for it, but behind the scenes, the query only gets one CPU thread. Its DOP is indeed 1. It doesn't test DOP upgrades, meaning that if you have, let's just, to make numbers easy, because I am not particularly good at math, let's say that you have a query running at DOP 4 that's hitting a 100 million row table. Let's go to 100 million rows. Let's really scale this thing up. You have 4 threads suffering with 25 million rows apiece. It does stand to reason, at least in my experience with query parallelism, that if we were to alleviate some of the stress from those 4 cores and maybe bump it up to 8 cores, and we would have roughly 12.5 million rows per thread, each of those threads would be under far less stress and strain. We could probably have a more efficient query, but degree of parallelism feedback will not test that for you. You don't get that. You get the same dumb DOP 4 plan without any hope of a parallel upgrade, which is pretty goofy. If you want my honest feedback, that's just plumb goofy. It also won't test upgrades from a serial plan to a parallel plan. That doesn't happen. Probably get some more malarkey about needing a recompile, but we all know that's not particularly true. Yeah. And so, like, if you have queries that are running for, I don't know, 5, 10, 20, 30 seconds, and there is nothing specifically inhibiting them from going parallel, then why not test an upgrade to a higher DOP to bring the duration of those queries down? Since this is something that is not permanent, it is impermanent. That's one some might say. Why not just test it and see if there's any dramatic decrease in overall query duration at higher DOPs, like say 4 or 8. Eight's a pretty good number for most DOPs, as long as you have the CPU cores to back it up. So that's a pretty disappointing thing there. Now, this feature really feels like there was no adult in the room at the time when it was decided on. This feels like developer pizza, where they decided that they wanted to you know pick out like the grossest pizza, and like teenagers sitting there with a menu being like, "Ew, tuna fish and gravy" or something, like just like picking out intentionally gross pizza toppings. This is just not a very good spec for this thing. I can't imagine that there was very good telemetry involved in deciding on this one. It just kind of feels like a what if. Like developers get one wish per release, and this was the wish. Now, for a very, very long time, SQL Server has had the cost threshold for parallelism setting. And this setting has led many, many people to think that query cost is a very important metric. And I guess it is in the because it does, if a query costs under your cost threshold for parallelism setting, and it would be reasonable for that query to go parallel, but it does not get considered for parallelism because it does not have a high enough cost to go over your cost threshold for parallelism setting, then you could have some issues. But far more often, I find that servers running at the default cost threshold for parallelism setting have far more problems than folks who have raised it up and might have a few straggler queries that could use some help. Now, way back when, the cost threshold for parallelism setting is, or rather, meant seconds on one guy's computer named Nick in like 1997 or something. At least that's the folklore around it. And there are still people I talk to today who think that cost threshold for parallelism means seconds, which is kind of weird. But I think that, well, two things. One, nitpick is that the cost threshold for parallelism settings should be part of the SQL Server installer. MaxStop is in there, has been in there for a few releases now, and I think it would be a generally useful thing, since most sane and rational people, after they install SQL Server, will set cost threshold for parallelism away from the default. Whatever they set it to is better than the default, unless they set it lower for some reason. That would be a weird choice. Most folks I know will start at 50 and then adjust as necessary from there, assuming that 50 is not a successful change for them, or not a completely successful change for them. I think that a much better addition to SQL Server than degree of parallelism feedback, which only focuses on downgrading parallelism, would be a setting that would allow you to allow SQL Server to explore parallel plans for queries that do not break the cost threshold for parallelism setting, and look at their overall duration, perhaps their weights as well, if that's the kind of thing that you care about, and figure out if a parallel plan would be better. It would also be good if we could test parallelism at higher DOPs up to some upper limit. Whether that's configurable or that's just based on some internal math. And you can look at the number of cores and all that good stuff, cores and sockets and things that people really think hard about when they're setting max stop and all that. Figuring out NUMA, getting crazy in there. But I think a much better setting would be, to figure out at what threshold you would want to explore a parallel plan for a query that was deemed not expensive enough by the optimizer to consider a parallel plan for, because that would take a lot of the risk out of adjusting cost threshold for parallelism. Just to throw a number out there, let's say that you change cost threshold for parallelism to 50, and there's some really important query that has an estimated subtree cost of 49.9 query bucks, does not quite break that threshold, and you have a regression to a parallel plan. Well, this would take a lot of the sting out of that, because if that thing ran for, let's just say, 10 seconds, the the SQL Server's internals looked at that and said, "Oh, 10 seconds? Well, that doesn't seem that's not very fast. Let's try DOP4." Okay, now let's just say that it like the parallelism scaled linearly, and now the whole thing runs in like 2.5 seconds. Well, that was a successful introduction of parallelism to a query. I realize that there is inherent risk with introducing parallel queries or upgrading parallelism that downgrading parallelism does not have. The whole issue of parallel queries and worker threads and all that stuff. There is risk in there, but I think that is a risk that most workloads do not have. And the fact that this setting is one that you can turn on and off is one that you can use to mitigate those risks a bit for anyone out there who has a workload where they're at risk of that. But I think most people who have workloads where they're at severe risk of that are at least fairly well managed as far as DBA staff and all that stuff goes. So anyway, those are my thoughts on the degree of parallelism setting. It's not a terribly good feature. I've seen the demos for it. It's not very interesting. DOP goes down, doesn't go up. And that's about it. I don't know. Maybe this will be one of those things that just no one ever turns on and it dies on the vine, and that'd probably be the best thing for it unless significant improvements are made or other settings are introduced to allow you to better control parallelism on the server, specifically going from a serial plan to a parallel plan where it would be more efficient to do that. Anyway, that's it. Thank you for watching. You may not have learned anything, but hopefully you enjoyed yourselves anyway. I'm gonna go eat lunch now, I think. Brush my teeth after that. Make my dentist happy. I don't know. Maybe then I'll go for a walk. We'll see what happens. Anyway, thank you for watching. Remember, like, subscribe if you're into that sort of thing, if you're that kind of YouTube fanatic, and also that kind of SQL Server fanatic. And I will see you in another video that'll be back to more of the regularly scheduled content. Anyway, thank you again for watching.